Good morning, students. Today we will be reading or going through Electrogoniometry, a comprehensive guide. The topic today is Electrogoniometry. We are basically dealing with kinesiological tools and for assessment of functional movements in biomechanics. And one of the tools we use nowadays is electrogoniometry. Now we all know about goniometers, and these goniometers which we use are manual ones, which have got two arms and a protractor. It was initially a fluid goniometer, then gravity induced goniometer was there, but now we have come up with the technology. There's a change which has happened, and because of that now we are using is electrogoniometer. So what is an electrogoniometer? It is a specialized instrument used for measuring joint angles and is an indispensable tool of kinesiology and biomechanics, used in various healthcare settings, especially in physical therapy, rehabilitation, and sports medicine. This is going to be the importance of it. Now, if you see this diagram, you see for yourself, this is the electrogoniometer. And in this, you can find it helps us, one of the objectives of it is it gives us kinematic measurement of human motions. So it uses angle sensors to measure the dynamic movement of the joint. And it has got two arms, and it is attached to the proximal and the distal to that of the joint, and a potentiometer is attached. You can see this potentiometer and two arms, and they basically they tell us, they objectively measure the kinetic motion or the kinetic movement of the joint. Now, if we see the history of the development of electrogoniometer, early in if we say before in 80s, there was a mechanical system was there, and then we have to type on the computer the analog bit for the analog display. With the advancement in electronics in mid 20s, that is in the 21st century, there was digital displays came into being, and there was data storage was easy. And in modern electrogoniometers, you see there is a digital sensor technology has started, where there you can see there is real-time data analysis can take place. There's wireless technology is there, and advanced features are there. So if we now go in detail how this evolution of electrogoniometer is took place, in 1917 and 80s, there was an introduction to digital systems, and there were first time from the manual systems to the digital system. The first time a digital analog was used to was used for the accuracy and data processing capabilities, and it was used first time for the research and the clinical applications. Advancement in sensors, improvement in sensor technology, and using of strain gauge or potentiometer to tell you the reliability of this goniometer for accurate measurement of these angles. Around about in 1990s to 2000, there was miniaturization. Miniaturization means here that in 1970s and 80s, it was a huge cumbersome method to use this electrogoniometer. And now it should be in 19 and 2000, we got to know that it should be a portable device, and it should be wearable, and it should be like when the movement is taking place, then these goniometers should assess the movement through all the three degree angles, three axes. So wireless technology was helpful over here, and real-time assessment was started. Whereas nowadays, what we are doing is we want high precision. Since in 2000, there was not good precision was there. The movement, the sticking of electrodes, it was all cumbersome. Now in 2010, the accuracy we are using is micro electromechanical systems. We are using this in our modern electrogoniometers, and we are integrating this with our AI, real-time feedbacks, and complex analysis with mobile phones. And the key development and about this is commercialization. The aim is now we are using this for sports sciences, rehabilitation, and robots. And we are also using augmenting reality, virtual reality integration, and data interpretation is very nicely done through MATLABs and other softwares. So this is basically used in ongoing researches, and it is widespread used in now in sports sciences, in robotics, in rehabilitation, and biomechanics. Now, if we see the working of this electrogoniometer, it has got two arms. Electrogoniometer has got two arms which are strapped to the body segments, and an axis of rotation of the goniometer is aligned with the joint axis of rotation. And the potentiometer is basically, you can see over here, the potentiometer is basically calibrated so that the angular movement of the joint has been captured. And as soon as the angular movement of the joint, it is converted into voltage, and then it is multiplied this angle. To get an angle, it is multiplied by a scale factor. So this is how a typical thing is done. The related output voltage is typically measured by a computer data acquisition system, analog to digital system, and which displays the joint angle in real form and real time. Fine. And this, by if we know that angle, we can convert this mathematically to angular velocity as well as in acceleration. Now, it can be a potentiometer base, or it can be a rotatory encoder, or nowadays digital sensor. Any of this can be used along with the two arms. The one is potentiometer, as I told you. The potentiometer has got a variable resistor to measure the change in resistance as the joint angle changes, and it is directly proportional to the angle. The other method is to rotatory encoders, like similar to the potentiometer, but here it tracks the angular movement of each joint, and but thereby we can reflect the angle. Digital signals can be displayed. Rotatory, all the 3D motions can be done, which was a very significant role in 2010. But nowadays we are using is digital sensors. Now digital sensors basically use accelerometer, gyroscopes. They basically change in the acceleration and angular velocity and real-time data of the joint motion. They keep on changing with this digital sensors. Now these goniometers can be a single axis as the joint, and there are different type of joints which are available. So single axis joint, multi-axis joint. So the single axis joint, there were single axis goniometers are there. Multi-axial joints like shoulder joint, you can see there we want 3D movement. So there are multi-axial goniometers are there, variable goniometers. Now we want these goniometers to be worn when we are going for gait analysis or any movement analysis. So they are variable goniometers. So these are different types of goniometers which are there. Now the systems which they use, the systems, as I told you earlier, it can be an optoelectronic system which we use nowadays. That is, we use markers. Basically we use video cameras to track the markers which are located in the body, and these markers are basically infrared rays or light emitting diodes, or a solid shapes, or with shapes which have reflective tapes on it, so that we can the system tracks the vertical and the horizontal coordinates of each marker, and the computer software processes this information and determine the angle of the body segment. So we use optoelectronics, and then use the data analysis to get the data. Now potentiometer was the earlier method which we use. Basically electrical resistance was measured in voltage, and then angle was measured, that the joint angles was measured, and the strain gauge method, which is called as flexible goniometer, a variable goniometer. Now variable goniometer is a strain gauge is used. It's a had got a flexible spring basically, and a plastic blocks which are attached to it at the end. Now this is basically attached to a spring, and electrical resistance, it changes with its electrical resistance, and it is that is directly proportional to the change in the angle along with the longitudinal axis. So this is very lightweight, easy to move along with the patient's body, easy to adapt to the patient's body segment. So nowadays we are using flexible goniometer along with the optoelectronic systems. But potentiometers we have, because we used it till 21st century, that is in 2000 we were used to use potentiometer, but now we have moved towards the flexible goniometer, and which digital displays are there along with the markers. Fine. So you can see I wanted to show you this. This is a flexible goniometer. First, this is a strain gauge type, where you can see the strings and the springs are there. It molds according to the body segments. The two arms and the potentiometer is on the left, which you can see, and it is a very cumbersome method. Whereas you can see, get into know only single axis joint movements can be done input with the help of a potentiometer. And nowadays we are using optico-electronic sensors. You can see the sensors on the foot and how they help us to display the different motion which is happening on the foot when the person is walking. Fine. So advantages of using this electrogoniometer is objective advantage. That is, they are able to get the joint angles, and we are able to tell you, objectify and quantify our data. It is a real-time display. The person can correct himself along with this data itself. It is an accurate way, and it is versatile, that we can use in various rehabilitation and sports, ongoing analysis of sports performance. Fine. So what are the limitations? Sensor placements. If the goniometer can only work if the placement is correct, then only, otherwise the angle will not be correct. Skin movement. If the skin moves, the angle will also move. And they need to be calibrated for the accuracy. You know that calibration is very much in, that is without any zero error. Now, this kind of a calibration, what all calibration you have to do in electrogoniometers is 0 point calibration, one, which is it should be always in a neutral position. Then range of motion calibration, that is, it should assess the full range of motion, and then you have to take it and compare it with the standard one, so that we come to know whether it is taking the full range of motion calibration is done or not. And dynamic calibration, that is, you need to calibrate the electrogoniometer when the person joint is moving, so on the spot and accurate for the accurate reading. Fine. This is used in gait analysis, where we have seen in the practical class how the analysis of gait was done through the different markers and videography. And then we about all the pelvis movement, hip, knee, ankle joint movements, the trunk movements, the upper limb movements. The range of motion could be properly assessed, or the pelvic rotation was totally assessed through an electrogoniometers and through the optio electronic sensors. Joint stability analysis, whether there is any ligament instability or not, can be known through an electrogoniometers. And postural assessment, of course, can be done. It can compare your body position to the ideal position. Fine. So it has used in rehabilitation planning. It is used in improve the performance analysis, enhancement in cases of athletes' performance, and it's also helpful in injury prevention, because it identifies the wrong movement patterns, and that can be corrected, and thereby we can prevent the injury. So future area is when with artificial intelligence, if we integrate this data and we give them these data, or electrogoniometers should be given to the athlete itself or to the patient itself to correct himself at home. So there should be future advancement in electrogoniometers technology, where these setups or integrating the AI algorithms and real-time analysis of data should be done, and so that the patient can use it at home, visualize this data, and correct his posture, correct his joint position, and it should be very much wearable. Like we have smartwatch, we have everything, smart rings. So they keep on assessing our data and keep on telling us. So this is a very good way of future advancement in electromagnetic. Thank you.